Hello everyone, this is Seda Tüzün Canadinç and this is my final project's presentation, Arch 655 Parametric Modeling in Design. The class is given by Professor Dr. Wei Yan, and in this final project I'm going to use my first project model. It's Villanurbs in Spain, which is designed by architect Enrique Ruiz Geli. First of all, in Rhino I put the points and then create my NURBS curves with combining these points. I also draw these control points of curves of the sections and sweep them in Grasshopper. This is the roof boundary. This is the skin, and this is the bottom. This is what I need for this project. After finishing my model, I analyzed the radiation with Ladybug plugin. So first open the weather file. I downloaded the weather file from energyplus.net. I use Spain Girona EPV file. Let's open it. After opening the weather file, this is the radiation analysis. I put north. I define north by unit by a vector, and this is the location exactly as in the Google map. And there is the grid size. This is a parameter. I set it to 8, but it could be changed. And radiation analysis is giving me the radiation results, which I used for designing my new facades. And I also use SunPath. For the SunPath, I define a conditional statement for dry bulb temperature and radiation. And when we look at the SunPath, we can see this is the dry bulb temperature and this is the global horizontal radiation. At first it was not like this because of the normals of this skin is not correct. So I have to flip it and then use this flipped one as geometry. And after that I use the radiation results as values as an input for my Weaver-Bird stellate commands. But before that I have to flatten them, and I use a Python node for using these values because I assigned them smaller values and used these smaller values as heights of these pyramidal forms. So this is the inside of the Python editor. These are the assigned values. These are smaller. And after that, let's look at the web stellate. The logic in this Python assigning values is for these are gaining less sunlight. The red ones are gaining more sunlight. So the higher the value, the less the height, the less the radiation, the more the height. Let's see it. When we look at the blue parts, we see the height is more than the red ones. This is my first facade. I also tried 2 more facades. Let's look at them. This is the second facade design, and I used the web stellate mesh output of it. And by using Weaver-Bird's picture frame, I designed a new facade, but this time the values are not matching. The counting of the values are not matching because in this web stellate the mesh has all the pieces have 4 sides, and the Python command, the output is only one value for each square. So we need to match them. In order to match them, Weave node is used. Let's see the results. And this is the results. We see the picture frames in each of these squares, and the pyramidal the height of this pyramidal is still, you can see the pyramidal shape. But this have to be improved because in some places there should be more thickness. And let's see the baked one. This is the baked one. And lastly, I'm using paneling tools for panel wall design. I'm again using these radiation values coming from radiation analysis and the same node, Python script, and using some domain surface, grids, and dividing commands, extrusion, attractors, and generating borders, and then evaluating them with the formula, lines, point attractors, and finally NURBS curves on the surface. And this is the result. Since I'm using the same values, radiation values, more sunlight means more sunshade, less sunlight means less sunshade. And this is the final result. This final result also has to be further improved. Thank you for watching.